The discovery of DNA's structure changed the world forever and is still leading to groundbreaking advancements in medicine, bioengineering, and DNA technologies. It also answered the question, what makes us human? What makes us different from animals? This is Cambridge University in Cambridge, England, and this is where the whole discovery took place. It was credited to a few scientists, though many were involved. Here are some of the scientists that were involved in this discovery. On the left is Francis Crick, born in 1916. Crick got a bachelor's degree in physics from the University of London. On the right is James Watson, Crick's partner. He was born in 1928 and got a degree in zoology from the University of Chicago. He also has a doctorate from the University of Indiana. Maurice Wilkins was born in 1916 in New Zealand. He was a nuclear scientist and physicist and worked on the atomic bomb before he worked on DNA. Rosalind Franklin was born in 1920, and she was Maurice Wilkins' partner, though they hated each other. She was the only one of the 4 scientists so far who had a degree in chemistry. The final scientist racing to find DNA structure was Linus Pauling. He was born in 1910 and was a chemist at Caltech. Now that we've met these 5 scientists, it's very crucial to understand how they went about their research. Wilkins and Franklin, the 2 King's College researchers, went about gathering data through X-ray crystallography. X-ray crystallography, or X-ray diffraction, is the process in which X-rays are fired through a crystalline structure, in this case DNA, and then diffracted out in many directions. This pattern is then captured on film and analyzed. Watson and Crick, on the other hand, used data that had already been gathered to build a molecular model of what they thought DNA might look like. They then checked to see if this aligned with what we already knew about DNA, which wasn't much. However, we did know some things about the structure of DNA. We weren't completely oblivious. One thing we knew was discovered by a scientist named Phoebus Leven in 1920. He discovered that DNA is made up in part of these things called nitrogen bases, more commonly known as A, T, G, and C. Well, how does that help us? We now know what bases are, but we know nothing about them. Well, in 1950, a man named Erwin Chargaff discovered that the bases A and T always occurred in equal amounts. There was always the same number of A's as T's, and there was always the same number of G's as C's. But there weren't the same number of A's as C's, so there must be something special about A's and T's and G's and C's. That discovery led people to do one of the most revolutionary of human things, think. And one of these people was John Griffith. He decided that if the bases A and T and G and C occurred in equal amounts, then they must be paired together. Also, Rosalind Franklin did some experiments and then deduced that DNA must have a sugar and phosphate backbone, and that the bases would then be arranged along that backbone. So now we know that DNA is made up of bases, and that some of these bases occur in equal amounts, and that they're also paired up. We also know that DNA has a backbone of sorts made up of phosphate and sugar. Well, there's one final thing that has to be true. It has to replicate. Otherwise, you'd only have a few strands of DNA. Each cell needs DNA, so it has to replicate when the cell replicates. But how? Taking all of this into consideration, Watson and Crick built their first model of DNA. This model went over very badly and was ridiculed as ugly, inside out, and not based on the laws of chemistry. Then, in 1953, almost a year after Watson and Crick's failure, Linus Pauling published his model of DNA. It was a triple helix and was almost identical to Watson and Crick's failure. Also, it wasn't even chemically an acid, so there was no way it could be DNA, or deoxyribonucleic acid. The event that happened next changed everything. This picture of DNA taken by Rosalind Franklin is known as exposure 51, and in 1953, Maurice Wilkins showed it to Watson. This in turn gave Watson and Crick all the information they needed to build their model of DNA. Finally, they came to this, the first ever model of DNA structure. Furthermore, they published their findings on April 25, 1953 in the esteemed science journal Nature. So great was their discovery that in 1962, James Watson, Francis Crick, and Maurice Wilkins won Nobel Prizes in medicine.
Suddenly to see the molecule which is responsible for heredity and which makes possible human existence was a very big step in such a man's understanding of himself.
So what does this molecule look like? Well, in fact, it looks a lot like a ladder, with two sugar and phosphate backbones on the outside. Then, the bases are on the inside, A's with T's and G's with C's. This is then twisted into the iconic double helix, the structure of DNA. At this point, you might think DNA's story would be over. Well, you'd be wrong. The discovery of DNA's structure has changed the world both socially and culturally. Furthermore, it has led to new discoveries every day in agriculture, medicine, and science. To help get my head around such big concepts, I talked to Ola Sodenda, a micro and molecular biologist at Penn State University. One of the major advancements Ola talked about was GMOs, or genetically modified organisms, plants or animals whose DNA has been modified to make them bigger, faster growing, or more resistant to pests.
So the ability to make those kinds of crops, things like soybean, corn, maybe even tomatoes and things like that, really depends on the ability to clone genes. And so the ability to do that really depended on having a very good understanding and appreciation of the structure of DNA, and that came from Watson and Crick.
So without GMOs and their high yield, America wouldn't be able to support its growing population. So the discovery of DNA structure really was a turning point. However, knowing DNA structure has also affected medicine.
There are many drugs that are now being made by recombinant DNA technologies, things like insulin to treat diabetes and growth hormone, and many, lots and lots of drugs like that. Many of these drugs are now based on recombinant DNA technologies. And these so-called recombinant DNA technologies are really based on using the principle of DNA replication. And the principle of DNA replication really came from understanding the structure of DNA that Watson and Crick gave us.
Medicine and food production, however, barely scratch the surface of the things we can now do knowing DNA structure. One of these things is sequencing DNA, or analyzing it for certain diseases or traits.
To sequence maybe about 1,000 base pairs, at least in my hands, in 1983, it took me about a year. You sequence today overnight 1,000 times that much.
It is this, DNA sequencing, that has led to some of the biggest advancements of all. It has led to DNA analysis at crime sites and genetic screening to test the health of babies. It has even made it possible for humans to tell if they're more prone to certain cancers or hereditary diseases. However, some people still argue if it's ethical for humans to have this knowledge. Either way, none of this would have been possible without knowing the structure of DNA, the secret of life.